Hi students, this is Alex here. In this video, we are going to discuss about critical values. Critical values are those which makes the first derivative 0. So, it is a value of x which makes f dash of x 0. And it is also the value of x which makes f of x not defined. Let's solve some problem where we have to find the critical values. Number 1, f of x is given as 2x cubed minus 3x squared minus 36x. So as per the procedure, we have to find the first derivative, which is 6x square minus 6x minus 36. We have to equate to 0, and throughout all the term we can divide by 6. So it will become x square minus x minus 6 equal to 0. After factorizing, the product is minus 6, sum is minus 1. So the two numbers are 3 and 2, where 3 is negative. So after factorizing, we get two factors, x minus 3, x plus 2 equal to 0. So by taking each factor separately to 0, we get two values, and these are the critical values. So critical values are 3 and minus 2, because when I put this value in the function, that is in the first derivative, it makes 0. Another question, f of x is given as x minus 1 by x square minus x plus 1. So we have to follow u by v rule to differentiate this. So the formula is v u dash minus u v dash by v square. So f dash of x is going to be v. We have to write as it is x square minus x plus 1 into differentiation of u is 1 minus u, we have to copy as it is, and the differentiation of the denominator is 2x minus 1 whole divided by v square, that is x square minus x plus 1 whole square. Well, let's simplify the numerator. This is x square minus x plus 1 minus open bracket. By multiplying this, we get 2x square minus x minus 2x plus 1 whole divided by denominator as it is. Once again, in the numerator, the first terms are written as it is. When I remove this bracket, all the term will become negative. That is the opposite sign, because we have negative sign outside. So minus 2x square, and this will become plus x plus 2x, then minus 1 whole divided by x square minus x plus 1 whole square. So here you can cancel minus x plus x and plus 1 minus 1. Then we can combine these two like terms. So finally, by combining these two terms, you get minus x square, then 2x is remaining in the numerator, whole divided by x square minus x plus 1 whole square equal to 0. Then if I take the numerator part 0, we can take x common, so minus x plus 2 equal to 0, and equating each factor to 0, we get x is 0 and x is 2. But here we have to take denominator and equate to 0, but we don't get any real values, because when x square minus x plus 1 equal to 0, no real roots. So we ignore that. The critical values are only 0 and 2. Here this f dash of x, when we equate to 0, we have taken numerator separately equal to 0 and denominator separately equal to 0. Equating denominator to 0 is must, because then only we can find the value of x which makes the function not defined. So in this case there is no real values, so we have only critical value from the numerator. And in the previous problem it is not in the numerator and denominator form, so we have just one term and we equate it to 0. Now let's see the next problem. First step, we have to find f dash of x. Using the differentiation formula, this is 3 by 4 x power 3 by 4 minus 1 and minus 2 into 1 by 4 x power 1 by 4 minus 1. So this is 3 by 4 x power, after taking LCM, minus 1 by 4. We can cancel these two. So minus 1 by 2 x power, by simplifying this we get minus 3 by 4. Then let's carry both the term to the denominator. So x power 1 by 4 minus 1 by 2 x power 3 by 4. Now next step, let's take LCM. So take all the terms together. 4 x power 1 by 4 into 2 x power 3 by 4. So we have to multiply this 3 with this entire term. So we get 6 x power 3 by 4 minus, and this entire term we have to multiply with 1. So 4 x power 1 by 4. Then in the numerator we can write 6 x power 1 by 4 whole cube, because x power 3 by 4 can be rewritten like this, and the other term we can write as it is, and in the denominator we can multiply the numbers first. 4 is 8, and when I multiply the x terms you have to add the power. So 1 by 4 plus 3 by 4. Then further simplification, in the numerator we can take 2 common and the x power 1 by 4 common. After taking, this will become 3, and we have whole cube. So we have taken one term outside. So remaining will be whole square. And here when 2 is taken common, remaining 2 will be there, and this x power 4 is already taken common. And in the denominator it is 8 x power. We add this 4 by 4, which is 1. So it's only x. Then we can cancel this and this. It will become 4, and I can bring this term to the denominator. So numerator 3 x power 1 by 4 whole square minus 2 whole divided by 4 x already we have, and this comes down, it will become x power minus 1 by 4. Then in the numerator 3 we can multiply these two terms, it will become 2 by 4. X power 2 by 4 is after reducing 1 by 2 minus 2 whole divided by 4 x power, this is 1. We have to combine the power. 1 minus 1 by 4 is 3 by 4. After this we will equate to 0, and separately we equate the numerator to 0 and denominator to 0. From this we get 3 x power 1 by 2 equal to 2. X power 1 by 2 is equal to 2 by 3, and we have to square on both the sides. So x will become 4 by 9, and here x power 3 by 4 will become 0, because this 4, if I take to the other side, 0 by 4 is 0, and since x power 3 by 4 is 0, x is also 0. Therefore we have two critical values. One is x is equal to 4 by 9 and the other is 0. Next problem, f of x is equal to x power 3 by 5 into 4 minus x. So first step, f dash of x, since it is a product of two terms, we follow UV method. So the formula is u dash v plus u v dash. So derivative of x power 3 by 5 is 3 by 5 x power 3 by 5 minus 1, and we have to copy the v term as it is, plus we have to copy u term as it is, and derivative of 4 minus x is only minus 1. Again this is 3 by 5 x bar. After taking LCM, 3 by 5 minus 1. So the LCM is 5. So it is 3 minus 5. Totally minus 2. Minus 2 by 5 into 4 minus x. And this is minus x bar 3 by 5. Now we go for taking this term to the denominator. So we have 3 by 5 into 4 minus x whole divided by x bar 2 by 5 minus x bar 3 by 5. We have to take LCM. It is 5 into x bar 2 by 5. In the numerator, first term will be as it is, and the second term we have to multiply this entire term with this. So we have the number 5, and when you are multiplying, power will be added. So 2 by 5 plus 3 by 5. By adding this, we get 5 by 5, which is 1. So it is only x. Then after this, we will expand the numerator. So it is 12 minus 3x minus 5x whole division 5x bar 2 by 5. So finally, the numerator is 12 minus 8x by 5x bar 2 by 5. We have to equate to 0. For finding the critical value, we equate numerator separately to 0 and denominator separately to 0. By equating this to 0, we get 8x equal to 12 and x is equal to 12 by 8. After cancelling with 4th table, we get 3 by 2, and here x is 0. So we get two critical values. One is 3 by 2 and other is 0. Next problem, we have f of x is equal to x square plus 2 by x. First step, f dash of x, differentiation of x square is 2x and differentiation of 1 by x is minus 1 by x square. So we have 2 here, so it will become minus 2 by x square equal to 0. Now let's take LCM. LCM is x square. So the first step, we have to multiply this entire term with this. So we get 2x cube. Then we have minus 2. And we have to equate to 0. Here we can equate the numerator to 0 and denominator to 0 separately. But here this is not possible, because if I take this as 0, then x will be 0. But in the question f of x, we have x in the denominator. So the function having x term in the denominator, so surely this x cannot be equal to 0, otherwise this function itself does not exist. So using this value is rejected, because already from the question it is understood that x is not equal to 0. But here we are getting x is 0, but this is not possible. So we have the other term, and 2 is taken common. And when I carry this 2 to the other side, we get x cube minus 1 is equal to 0. 0 by 2 is 0. Then we have x cube equal to 1. So here we get cube root of unity. So x will be 1 power 1 by 3. For this, there are 3 values, but only one value is the real value. So this is only real root. Other 2 values are imaginary. Other 2 roots are right here. When x is equal to 1 power 1 by 3, we get 1 omega square, where this omega is minus 1 plus I root 3 by 2, and this omega square is minus 1 minus I root 3 by 2. But these two are not real roots, imaginary roots. So we take only the one real root, which is x is equal to 1. So the only critical value is x equal to 1. Question number 6. F of x is given as x square into e power minus 3x. So first step, we have to find f dash of x as usual. Since it's a product of two terms, we have to follow product rule. Its first term is u dash v and second term is u v dash. So differentiation of x square is 2x, and we have to take v as it is plus u we have to take as it is, and differentiation of e power minus 3x is minus 3 into e power minus 3x. So it is in the product. So totally we can take e power minus 3x common. This will become 2x, and this will become minus 3x square equal to 0. And these two products are equal to 0, and this we cannot take it as 0 because e power minus 3x cannot be 0, only this can be 0. And here we can take x common. After taking x common, we left with 2 minus 3x equal to 0. By taking separately equal to 0, we get x is equal to 0 and x is equal to 2 by 3. So we have two critical values, 0 and 2 by 3. Question number 7. We have f of x is equal to x square into log x. So let's rewrite this. We can write this as log x divided by x square. And we have to follow quotient rule. This is u and v, and differentiation of this will be u dash v minus u v dash divided by v square. So f dash of x is going to be, first one u dash, differentiation of log x is 1 by x, into v we have to copy as it is, minus u we have to copy as it is, differentiation of x square is 2x. Then we have v square, which is x power 4. Now we can cancel this. So this is only x minus this is 2x log x whole divided by x power 4. Then we can take x common in the numerator. We get 1 minus 2 log x whole divided by x power 4. So we can cancel this. We become x cubed. Now as per the procedure, we have to equate numerator separately to 0 and denominator to 0. But denominator we get x equal to 0. But already in the function we have log x. Here this log x is only when x is greater than 0. And inside log we cannot get 0 or a negative number. So x is only more than 0. Since we get 0 here, you can say this is not possible. So we ignore this. And from here, we get 2 log x equal to 1. So log x equal to 1 by 2. And by removing log, we get x equal to e power 1 by 2, which is nothing but root e. So the only critical value is x is equal to root e. Next problem, we have f of x is equal to 2 cos x plus sin square x. First step, f dash of x, differentiation of 2 cos x is 2 into minus sin x. Then differentiation of sin square x, we follow chain rule, which is 2 sin x into differentiation of sin x is cos x. We will take 2 sin x common. This will become minus 1 and this will become plus cos x. Now we will rearrange this. 2 sin x into cos x minus 1 equal to 0. From this we get 2 sin x equal to 0 and cos x minus 1 equal to 0. From this sin x equal to 0 and the value of x will be n pi, where n is an integer. Here we get cos x equal to 1. It means the value of x will be 0, 2 pi, 4 pi. So it goes in terms of multiples of 2 pi. And here it is n pi. So where n is an integer. So this solution is automatically covered here. Therefore, critical values are x is equal to n pi, where n is an integer. We have f of x is equal to 4x minus tan x. F dash of x equal to differentiation of 4x is 4 minus tan x differentiation is secant square x. As per the procedure, we equate to 0. From this, we get secant square x equal to 4, but secant square x is 1 by cos square x, which is equal to 4. By taking reciprocal, we get cos square x equal to 1 by 4. Again, cos x will be plus or minus 1 by 2. Let's split this into two parts. Cos x equal to 1 by 2 and cos x equal to minus 1 by 2. This can be written as cos x equal to cos pi by 3. Cos pi by 3 is 1 by 2. In the same way, cos x equal to cos of 120, which is 2 pi by 3, is minus 1 by 2. So I wrote directly 2 pi by 3. Here we are going to use a general solution for cos x equal to cos y. Then x is equal to 2n pi plus or minus y. In this first case, this is the value of y, and in second case, this is the value of y. So in the first case, we have x equal to 2n pi plus or minus pi by 3. And in the second case, x is equal to 2n pi plus or minus 2 pi by 3. We can leave the answer as it is, or further this can be split as x is equal to 2n pi plus pi by 3 and 2n pi minus pi by 3. But minus pi by 3 can also be written in the following way. So we have x-axis, y-axis, we have 4 quadrants, and minus pi by 3 is the one here from the x-axis in the clockwise direction. But this can also be written as this minus pi by 3 can also be written as 2 pi minus pi by 3, because this entire thing is 2 pi, it is coming down. So by taking LCM, we get 6 pi minus pi, which is 5 pi by 3. So in this place, we can also write plus 5 pi by 3. So again I'll write the solution. So first x is 2n pi plus pi by 3, that is one part, and another part is 2n pi, instead of minus pi by 3, I can write plus 5 pi by 3. In the same way, the other part. So this can be split into two parts, 2n pi plus 2 pi by 3 and 2n pi minus 2 pi by 3. So this minus 2 pi by 3 is something like this. So from here, it will come something like this. This is minus 2 pi by 3, but this can also be written as 2 pi minus 2 pi by 3, because from the 2 pi we subtract and come in the clockwise direction. Taking LCM, we get 4 pi by 3. After taking LCM, this will become 6 pi minus 2 pi, so 4 pi by 3. So once again, the solution can be rewritten as first part as it is, but the second part, instead of minus 2 pi by 3, we can write 2n pi plus 4 pi by 3. Here n is an integer. So we have 4 critical values in the general form. For every value of n, we have so many x values. So the critical points in the general form we got.